When a sample of natural copper is vaporized and injected into a mass spectrometer, the results shown below are obtained. Uses data to compute the average mass of natural copper. All right. Got a little data interpretation here to go along with this word problem. Let's use M1, mass of the first isotope, times its percent abundance plus the mass of the second isotope. Now I'm just going to make these different colors. Mass of the second isotope times its relative abundance. Add that to the mass of the third isotope times its relative abundance plus ... and you will get the atomic mass of all the isotopes, which is a weighted average. And we have two here, right? That's one, two isotopes of copper. Is that what it says? All right, good. Yep, these are the two. And it wants us to calculate this thing here. So straightforward stuff. Don't need any algebra. Let's just plug and play. All right, and we don't need that either because there's only two isotopes. I'll do isotope 1 in red. Let's just call that isotope 1. So that's where's 63? Oh, here it is. 63. The masses are there. That's 63. This is not 63. So the mass is 60. The more accurate mass is 62.93 atomic mass units, and its percent abundance is 69.09. Let's move that decimal over 2 spots to the left. I'm sorry, that percentage, right? Because it's per 100, which means if it's out of 100, it's percent, you can say. So let's turn that into decimal form. All right, let's add that to the mass of the second isotope, which is copper 65. Copper 65 has a mass right there of 64.93 atomic mass units, and its relative abundance is relatively to each other. It's 30.91%. Let's move that decimal over twice. Turn that into decimal form. I'm sorry, I keep saying decimal. Turn that percentage over into decimal form. 3091. All right, I'll be right back. I'm going to grab my calculator. All right, here we go. 62.93 times 0.6909. I'm going to do this separately so the sig figs are easier to see. All right, so there's my weighted mass, if you will, of isotope 63. And the next one is 64.93 times its percentage is I can see it off the graph there, 3091. And because it only makes up 30% of it, we would expect it to be less weighting, 20. All right, so now we can add these up. And there's our answer. Now, let's take a look at the sig figs here. Our first, well, all of them actually just had 4 sig figs times 4. So that 40.48, we need precision to the hundredths, and then the same case for the second isotope. 4 sig figs times 4 sig figs is 20.07. So again, both of those weighted answers have sig figs to the hundredths, 2 decimal places. So our answer has to have 2 decimal places. because we're adding at that point. All right, so let me do this. 43.48. So here, 43.48. And then 20.07. So now it's time to add it to get our final answer. When we add, you go by the placeholder. Now they both have the same number of placeholders to the right. So our answer has to have 2 decimal places, what I'm saying. All right, instead of adding these rounded numbers too, I use the better numbers in my calculator. So I got 63.55 is the answer. And that's your weighted average atomic mass, if you will. We just call it atomic mass of copper.